Hello friends, welcome back to our channel. So in today's session we'll go with a few more functions in Numpy, that is a statistical functions. Yes, so coming to the statistical functions, we are having a few functions, so we'll see one by one. So first of all, I will list out all the functions and then I will explain the syntax, then we'll see the implementation in the interpreter, right? So first one is a minimum function in order to find the minimum value. A maximum, so this can also be used to find the maximum value. And then average function, so in order to find the average, so here we can use the two ways. One is finding the normal average, another one is finding the weighted average. Okay, so for also weighted average we can use this average function. And in order to find the mean for given elements, so there is a function called a mean, and then a median. So I will explain everything. Okay, so median, in order to find the median value. Similarly, where function means a variance, okay, to find the variance of the given elements. And then STD, that means a standard deviation. Okay, STD is a standard deviation, right? So this is for finding the minimum element, okay, finding the minimum element. So we can also find this minimum element along the axis 0, axis 1, and also from the complete array. Similarly, Amax is to find the maximum element, okay, in all these three cases. So with respect to axis 0, with respect to axis 1, with respect to axis, complete array, from the complete array, ND array, okay, and dimension array. And this average can be used to find the average from the complete array as well as weighted average, okay, weighted average, right? Next, mean, used to find the mean of element, okay, mean. And then a median. So I will give the explanation, so how to find the mean and how to find the median. So of course you know, but just I will revise the concept. So next, the variance. Where is nothing but finding the variance of the elements in an array. And STD is for finding the standard deviation of the complete array, right? So we'll see one by one the syntax and all these things. So first let us start with the A minimum. So A minimum with a complete array. So just I will give you the array, right, I will close this one and I will take only one array. So A is equal to, so we have to use the array function to read the elements, or we can also go with the different functions we have seen, like range, line space, and all these things, right? So I will just we can initialize the array by using any one of the function. I will just take the elements, okay, so some 50, 10, 40, similarly 30, 60, 20, and 90, 70, 80. So this is the array, okay, this is the array. From this array we have to find all those things. So first we will find the A minimum, okay. So first we have to import the Numpy, okay, import Numpy as NP. So this is an important thing. So after that we have to call each and every function with the help of that alias name. So if you are not giving any alias name, we have to directly call with the module name, right? So here I am giving some alias name. So the np.amin of, so we have to pass only one element, that is a one argument, that is the array name. Here the array name is A, so I am giving A as a result. Okay, A as a parameter, so it will return the minimum element in all the dimensions. So what is the minimum element here? 10 is the minimum, so it will return 10. Okay, similarly np dot A maximum of A, it will give the maximum value, that means 90, it will return 90. Similarly np dot A minimum of A comma, here we can also find the minimum element along the axis, right? So here we can go with the axis is equal to 0. So in the previous session we have said that axis is equal to 0 means the column wise operations. See here the column wise operations, you can see 50, 30, 90 is the first column, 10, 60, 70 is the second column, 40, 20 and 80 is the third column. So among these things find out the minimum value. So we'll get an array. So first 50, 30, 90, 30 is the minimum, and 10, 60, 70, 10 is the minimum, 40, 20, 80, 20 is the minimum. So this will be the result for A minimum with axis 0. Similarly np dot A maximum of, okay, A comma axis is equal to 0. So here again I am giving the axis is equal to 0. Axis is equal to 0 means again we have to do the operations on column wise. Okay, column wise the highest element. So first column 90 is the highest element, second column 70 is the highest element, third column 80 is the highest element, right? So this will be the result for finding the maximum along the axis 0. Now simply we can go with the np dot A minimum of A comma, here just we will go with the axis is equal to 1. Axis is equal to 1 means row wise operations should be done. So in this row, in the first row, what is the smallest? Because we are finding the minimum value. So 10 is the smallest, so 10, second row 20, third row 70. So this will be the result for finding the minimum with along the axis 1. Similarly np dot A maximum of A comma axis is equal to 1. Okay, again the row wise largest elements. Among the first row 50 is the largest, among the second row 60 is the largest, and among the third row 90 is the largest. So this will be the result for this max function. So these are the ways, different ways to find the min and max functions. Okay, by using the min and max functions we can find the minimum and maximum value. So throughout the array as well as along the different axes, that means 0 axis and 1 axis, right? So don't worry, we'll execute this one, and so that if you are having any doubts, so that those doubts will be clarified, right? So this is all about these two functions. Now we'll go with one more function called average. So simply by using the np dot average, so just give one argument, that is A, which will give the complete average of all the elements, that means sum of all the elements by number of elements. So it gives a 50 plus 10 plus 40 plus 30 plus 60 plus 20 plus 90 plus 70 and 80 divided by, so how many elements are there? 9 elements are there. So this will be the result for finding the average. This will be the result for finding the average. And if you want to go with the weighted average, so I will just take the small values. Okay, so 1, 2, 3, 4, 5, 6, 7, 8 and 9. So these are the values of an array, right? Now we can find out. So if I want to give the weighted average, we have to take one parameter called weight. So we can, I will declare some weight, W is equal to, so I have to give the dimensions which are equal to the single dimension. So what is the single dimension here? The three elements are there in the single dimension. So here we can give the 3 elements, 1, 1, 1. So these are the weights given, and if you want to find the weighted average for this one, so go with the np dot average, the same function, pass the parameter, the function, I mean the array name, comma, go with the second parameter called weights. Weights is equal to W. Weights is equal to, give the name of that particular weight. Okay, comma, axis is equal to 0. Axis is equal to 0. So if your axis is equal to 0, we know that this one, column wise. So product of each column and weighted average divided by sum of weights. So here you can observe this implies 1 into 1 plus, here axis is 0, so next one is a 4, right? 4 into 1, so let us take 2 and let us take 3. Okay, then you will be understanding. So 4 into 2, 2 plus 7 into 3 divided by sum of all the weights, that means 1 plus 2 plus 3. So we can get as, so 1 plus 8 plus 21 divided by 6. So total we'll get, see 9, so 30 by 6, then we'll get a 5. So 5 will be the first one, and similarly the same thing should be calculated for the second column also. So 2 into 1, 2 plus 5 into 2, 10 plus 8 into 3, 24 divided by 6. So how much it was? 12 and 36. See 36 by 6. So we'll get 6 as the result. So 6 will be the second one. Okay. So here we are dividing. So we'll get the result as float values 5 dot 6 dot. Similarly here the third one, 3 into 1, 3 plus 6 into 2, 12 plus 9 into 3, 27 by 6. So 42 divided by 6, that will be 7. So 7 dot is the answer. So this will be the answer, right? So 5 dot, 6 dot, 7 dot will be the answer for this weighted average. So first we have to take the weighted weights. So weights which equal to the number of elements in each dimension, and then we can calculate the weighted average along with the axis. So if you play, this is for along with the axis 0. So 0 means column operations, right? Column operations. And if you replace it with 1, then row operations. So 1 into 1 plus 2 into 2 plus 3 into 3 divided by 6. Similarly 4 into 1 plus 5 into 2 plus 6 into 3 divided by 6. Similarly 7 into 1, 8 into 2, 9 into 3 divided by 6. So that should be calculated, and that will be the result of the weighted average along with the axis is equal to 1. So no worry. So we'll execute the same thing in the interpreter so that your doubt will be clarified, right? So this is all about the average function. Now we'll move with the next one, that is mean and median. Mean and median, right? So if you apply the same thing, so np dot mean of A, we'll get the simply average. Mean is nothing but an average, right? So we'll get this normal average. So 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 divided by 9. So this will be the result of mean. And if you go with, so we can also find the mean with the help of axis, right? So np dot mean, we have to pass array as a parameter, and the next parameter is axis. So axis is equal to some 0. So 0 means column operations. So 1 plus 4 plus 7, so 5 plus 7, 12 divided by 3. Similarly 2 plus 5, 7 plus 8, so 15 by 3. Okay, 3 plus 6, 9 plus 9, 18 by 3. So the result will be 4, 5, 6, 4 dots, 5 dot, 6 dot. This will be the result for finding a mean along with the axis 0. Similarly, np dot mean of A, and I want to find that along with the axis 1, so go with the row wise. Okay, row wise. So 1 plus 2, 3, 3 plus 3, 6, 6 by 3, 4 plus 5, 9, 9 plus 6, 15 by 3. Similarly 7 plus 8, 15, 15 plus 9, 24 by 3. So 2 dot, 5 dot, 8 dot, right? So this will be the result. So mean means just giving an average, finding the average. So that average can be found so throughout the array, or we can find the mean along with the axis, different axis, 0 axis and 1 axis, right? So this is all about the mean, and now we will find the median. Median, okay. Now I will change the things. So 4, 9, 8, 5, 7, What are the another things? 4, 5, 6, 7, 8, 9. So 1, 2, and 3. So let us take this one. So let us take this one. So we have to find the median. So in order to find the median, we have to go with np.median of, give the pass parameter as an array. Here first we have to sort the elements. So the elements will be get sorted. So the elements will be 1, 2, 3, 4, 5, 6, 7, 8, and 9. And median means finding the middle element. So you can find the middle element. So this is the middle element, right? So the result of this one will be 5, middle element. So if the number of elements are even, then we have to consider 2 elements. So for example, there are only 8 elements. So then we have to consider 4 and 5 as a median. Okay, we will get the result as 4 and 5. Now, we can also find the median with the help of axis. So along the axis A, and axis is equal to 0. So what is the 0? Row wise. So here you can observe, first we have to sort out, right? 1, 4, and 5. What is the middle value? 4. 2, 7, 9. So sorted order 2, 7, 9. So 7 will be the middle element. Similarly 3, 6, 8. 6 will be the middle. So this will be the result for a median along axis 0. And coming to the median along the axis 1, so row wise, so 4, 9, 8. So first we have to sort it. 4, 8, 9. So 8 is the middle value, and 5, 7, 6. So 5, 6, 7. 6 is the middle element. 1, 2, 3. 2 is the middle element. So this will be the result for median along the axis 1. Right? So this is all about finding the median. Right? Now we'll go with the variance. So how to find the variance? So variance. So for the variance, so first I will give the procedure. So first we have to find the mean. Okay. So mean is equal to, what is the mean for all these things? So 1 plus 2 plus 3. So you have to add all these things, right? So 3 plus 3, 6, 6 plus 6, 12, 19, 24, 32, 41, and 45. 45 by 9. Okay, 45 by 9, the mean value will be 5. So the mean value will be 5, right? So in order to find the variance, so variance is equal to, now make the difference of all the elements with the mean value and square. So 4 minus 5 whole square. So I will write down here. So mean is nothing but 45 by 9, which is nothing but a 5, right? Now I will take that one. So variance is equal to, so we have to calculate the variance. Variance is equal to, so 4 minus 5 square plus 9 minus 5 square plus 8 minus 5 square plus 5 minus 7 square plus 7 minus 5 square plus 6 minus 5 square plus 1 minus 5 square plus 2 minus 5 square plus 3 minus 5 square whole divided by the number of elements, that is 9. The number of elements divided by the number of elements 9. So first of all we have to find out the mean and difference this mean with each and every element. Okay, with each and every element. So 4 minus 5 square. So we have to apply the square also. 4 minus 5 square. So 9 is the second element. So 9 minus 5 square. 8 minus 5 square. 5 minus, sorry. Here 5 minus 5 square. 7 minus 5 square. 6 minus 5 square. 1 minus 5. 2 minus 5. 3 minus 5. So we can compute that and we have to divide it with by 9 so that this variance will be getting. We'll get the variance value. Okay. So we can also find this variance along the axis. So x-axis and y-axis. So 0-axis and 1-axis. So 0-axis means we have to calculate the operations towards the columns, and if it is 1 axis 1, so we have to calculate the operations on row wise. Okay, so we have to use the same formula. And coming to the standard deviation, that is simply we can write a square root of variance. That's nothing but a square root of variance. This gives the standard deviation. Okay, so giving the square root for all these things will give the standard deviation. Right? So for that we are having directly functions called np dot var a and np dot std, that means standard deviation, variance and standard deviation. Right? So hope you understood this one. So we have to calculate all these things, and don't worry, I will execute the programs and I will let you know, so that if you are having any doubts, so all those doubts will be get clarified. Right? So let us move on to the interpreter.
Yeah, hello friends. Just now we have seen the various statistical functions in Numpy. So now we'll see the practical implementation of these statistical functions one by one by executing the each and every function in the interpreter. Okay, so I'm executing all these functions using the Jupyter Notebook IDE. So we'll start with the first function, that is a minimum. So finding the minimum of minimum number in the array. So first that we have to import the Numpy package. So I'm giving some alias name so that we have to implement all these functions with the help of that alias name. Right? So this first I have imported this Numpy and I have given it the alias name as np. So first we will create one array, so with multiple elements. So for that we will use array np dot array function, and we'll pass the elements. So I will take some 10, 20, 30 and 50, 70, some 60. Okay, and one more thing, just 1, 2 and 3. Okay, I have created one array by using the array function. So we will print that array and I will show you. So this is the array we are having. So 10, 20, 30, 50, 70, 60 and 1, 2, 3. So these are the elements present in the array, 3 dimension, 3 by 3. Okay, so now we are supposed to find the minimum value in this array. So we can find the minimum directly. We can find the minimum value in the complete array, as well as we can also find the minimum element along the different axes. So we know that this array consists of two dimensions, I mean two axes, that is axis 0 and axis 1. So axis 0 represents the column wise and axis 1 represents the row wise. Okay, that we have explained in the previous session. So first of all, we'll check what is the minimum value in the entire array. So for that purpose we are going to use np dot a minimum. So there is a function called a minimum, and we have to pass the argument array in that a minimum, so that we'll get the minimum element throughout the array. Okay, this is the minimum element throughout the array. So you can observe here in the array we are having 9 elements. Among these 9 elements, this 1 is the minimum element, so we are getting the 1 as a result. Similarly, the same thing, maximum. Okay, so np dot max, a max of, we have to pass the array in which we want to check the maximum element. So you can observe here the 70 is the largest element among all elements in the array, right? So this is the normal procedure to find the minimum value and the maximum value in the array. But now we'll check the minimum value along one axis and maximum value along one axis. So first of all, let us check with the 0 axis. Okay, a max, a or a min of a, sorry, the first argument is a, so that means the array name, comma, and we have to pass the axis. Axis is equal to 0. So here axis equal to 0 means we know that the column wise, so 1051 among these columns, what's the lowest number? Similarly 2072. So among these 3 numbers, what is the minimum value? Similarly the third column 3063, what is the minimum value? So we know that by observing, so we can know that among these 3 columns the minimum values are 1, 2, 3. So we have to get the result as 1, 2, 3. So you can observe here. So we got the result as 1, 2, 3. And now we'll check for the along with the axis 1. Okay, axis 1. Axis 1 means row wise. So in the first row the minimum element is 10, in the second row the minimum element is 50, and the third row the minimum element is 1. So we have to get the result as 10, 50 and 1. So if you observe, you can get the result 10, 50, 1. So as I have said in the previous session, axis, so we can find each and every function along the axis. So if it is axis 0, then the computations will be done among the column wise, and if the axis is 1, the computations will be done among the row wise, right? Similarly, we can also go with the maximum function. So just we'll check with the maximum function. So for that we have to use the a max function. So a max of a along axis 0. So axis 0 means a column wise, so we have to find the maximum element along the column wise. So in the first column the maximum element is 50, and the second column the maximum element is 70, and the third column the maximum element is 60. Okay, so we have to get that result. Yes, so you can observe here, so 50, 70 and 60, right? So this is along the zero axis. Zero axis means column wise. And now we'll check with the row axis. Okay, that means 1. Axis is equal to 1. So if you put the axis equal to 1, we have to get the maximum element along the row wise. Okay, in the first row the maximum element is 30, in the second row the maximum element is 70, and the third row that maximum element is 3. So we have to get that result. So you can observe 30, 70 and 3, right? So this is how we can find the minimum and maximum elements throughout the array or along the axis, either 0 or 1. And the next function is, we have seen that is an average. So for getting the average of all the elements in the array, so we are using the function called average. np.average of, we have to pass the parameter as an array name. So whatever the elements, first we'll print the values of a so that you'll be understand. Okay, so print a, so we are having these values. So if you use the average function, the average of a, you will get the average of all the elements. That means, so sum of all the elements divided by number of elements. That's the average normally. So 10 plus 20 plus 30 plus 50 plus 70 plus 60 plus 1 plus 2 plus 3 divided by, there are 9 elements, so divided by 9. So that we'll get this result, right? So this average can also be done in along the axis, as well as we can also give the weighted averages. Weighted average. Weighted average means product of that particular number divided by sum of the all the weights. So I will show you an example. Okay, so we have seen the explanation in the just now. So this just we'll create one weight. So some w is equal to, so as we know that each index is having, each dimension is having 3 elements. We have to give the weights is also equal to the dimensions. Okay, so that means here weights should be also with 3 elements, 1 comma 2 comma 3. So here I am giving weights as 1, 2, 3. Okay, so I have executed. Now we will see the average, weighted average. So for that purpose we are going to use the same average function, but we have to pass the first argument as an array name and the second one as a weights. Weights is equal to give that particular weight w, right? So obviously the weighted average will be calculated. Okay. Oh, sorry. So here we have to give along the axis. Okay, here each dimension is having the 3 parameters, 3 elements. Here weights are also having the 3 elements, so we have to pass it with the axis, right? So along the axis we have to pass it. Otherwise we have to take the 9 elements and then we can use this weight average. Okay, so I will pass the axis, the third parameter axis as 0, so that we'll get the weighted average along with the axis 0. Okay, so here you can observe, so the result will be along along 0 means column, so 1 into 10, so first column 1 into 10, 2 into 50 and 3 into 1 divided by 1 plus 2 plus 3, so sum of weights. Okay, so product of weight with the elements divided by sum of the weights. So 1 into 10, 2 into 50 and 3 into 1 divided by 1 plus 2 plus 3. Similarly, the second element will be, so 1 into 20 plus 2 into 70 plus 3 into 2 divided by 1 plus 2 plus 3. Similarly, the third element will be 1 into 30, 2 into 60 and 3 into 3 divided by 1 plus 2 plus 3. So that we will get the result as 18.833 to 27.666 and 26.5. So we can also use this weighted average for along with the axis 1 also, so that it will be executing in a, the operations will be done on row wise. So you can observe. So there is a different result. So here the result will be, the first element will be, so 1 into 10 plus 2 into 20 plus 3 into 30 divided by 1 plus 2 plus 3, and the second element will be 1 into 50. So the operations will be done on row wise. So 1 into 50, 2 into 70 and 3 into 60 divided by 1 plus 2 plus 3. Similarly, 1 plus 1, 1 into 1, 2 into 2, and 3 into 3 divided by 1 plus 2 plus 3. So that we'll get the result as this one, right? So we have to perform the average. We can also find the normal average, or also we can also find the weighted average along with the axis. Okay, that's all about our minimum function, maximum function, and the weighted average. Now we'll go with the mean. So mean. So we know that mean means similar to our average function. Okay, so np dot let us take this one, print of a. So these are the elements. So np dot mean of a. So automatically we'll get the result, because so there's normal average. Okay, so you can observe here the normal average is 27.333, and mean also the same thing, 27.333. And apart from this, so mean means sum of all the elements divided by number of elements. So here we can also find the mean along different axes. So mean of a comma, you can simply give the axis number, or we can use the axis parameter. Okay, the axis is equal to 0, so that we'll get the mean along axis 0. Axis 0 means here, like this. So 10 plus 50 plus 1 divided by 3, 20 plus 70 plus 2 divided by 3, so 30 plus 60 plus 3 divided by 3. So like this we can also give this one. Okay, and also we can find the mean along with the axis 1, that means a row wise. So you can observe here. So this is the mean along the axis 1. Axis 1 means row, right? So this is how we can calculate the mean, and similar to that we can also find the median. So median, we know that finding the median means the center element. Okay, we have to sort out every element, sort out all the elements, and we have to find the median. The center of the elements. Okay. Now we'll see np dot median of a. So you can observe here, just if you see, if you give the, if you apply this one median to the array A, first it will be converted into a sorted order. Let us type here. So 10, 20, sorry, the first number will be 1, 2, 3, and then 20, 20, 30, and then it will be 50, 60, and 70. So what is the middle value? So here you can observe the 4 elements on left side and the 4 elements on right side. The the middle element will be 20. So the median of A will be obviously the 20. So first we have to sort out, and then we have to find the middle element. So if you are not having if you are having some even elements, we have to consider the middle 2 elements. Okay, see, the 20 will be the result. Okay, so hope you understood this one. So first we have to sort out all the elements, and then we have to find the middle element, and we can also find the median of given array along with the different axes. So first we'll check it out. So median of A comma, we have to use the parameter axis is equal to 0, so that we have to find the median of A along the axis 0. Axis 0 means here, so 1051, so column wise. So first of all we have to sort out. So 1051 means 1, 10, 50. So what is the middle element? 10. Among this second column, 2, 20, 70. So the minimum element, the middle element is 20. And here 3, 30, 60. The middle element will be 30. So the result will be 10, 20, and 30. So let us check while executing this one. So yeah, we got it. So we are having the 10, 20, and 30 as a result of finding the median along with the axis 0. Similarly, we can also find the median along the axis 1. So see, along axis 1 means just finding the median along the row wise. So coming to the first row, already these are in ascending order. So the middle element is 20, and coming to the second one, it is not in ascending order. We have to sort out. So 50, 60, 70. The middle element will be 60, and the third row is again in a sorted order. The middle element is 2. So the result will be 20, 60, and 2. So we'll check it out. See, you can observe here 20, 60, and 2. The result will be the 20, 60, and 2. So this is how we can find the median along the axis 1. Okay, so we can find the median and the mean along with the axis 0 or 1, or else we can also find the median and the mean throughout the array, right? So these are the two other functions, and one more function we can find are variance and standard deviation. So first of all, we'll check the variance. So np dot variance of A, np dot variance of A. So it will give the variance, it will calculate the variance, and it will return the result. Similarly, we can check with the standard deviation, that means square root of a variance. So we can get the value of standard deviation by calculating the square root of variance. So np dot std of a. So for calculating the variance, we have to use a var function, and for calculating the standard deviation, we have to use std function. Okay, standard deviation. So if you execute this one, we'll get the standard deviation for that one. So you can observe here the variance is 632 for the above elements. Okay, and we have given the elements 10, 20, 30, 50, 70, 60, and 1, 2, 3. So for variance, I am getting the result as 632. So as I have explained how to calculate the variance just now. So by calculating that one, we get the 632, and in order to find the standard deviation, just simply the square root of variance will get the result. So square root of 632 will be 25.144029, right? So this is how we can apply the various statistical functions. So a minimum, a max, mean, median, weighted average, variance, and the standard deviation. So these are the various statistical functions used in Numpy, right? So hope you understood this session. So if you are having any doubts regarding these statistical functions in Numpy, so feel free to post your doubts in the comment section. So definitely I will try to clarify all your doubts. So if you really understood my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.